Okay, so previously we discussed about the double angle formula, for which when you have theta and you have twice of the theta, so what formula you can use. And for half angle is going to be opposite of that. If you have theta and you actually have half of the theta, so what formula you can actually use to deal with that problem. So of course they're going to be different function according to different trigonometric functions. You can have a different property for sine, cos, and also tangent. And tangent is a bit special for this case. So we have three different form of tangent alpha over 2. And as what we have seen for cos 2 theta previously, so you can actually pick any one of this form, so according to what suits the problem that you're trying to solve. Okay, so let's start with the first example. What I'm going to do here is that I'm going to use cos of 210 degree, which is equivalent to negative square root 3 over 2, to find the exact value of cos 105 degree. Okay, so first of all, I would like you to notice the fact that for sine and cos, so we have symbol plus and also minus. So whether it's going to be plus or minus, it's going to depend on where where the angle is positioned, and this is going to be done whether it's going to be positive or negative, so that is going to be according to the cast rule. Okay, first of all, I'm going to have to try to relate between these two. So what is the relationship between 210 degree and cos 105? And in this formula, so I have to substitute a value of cos of alpha, and because we have to use this value, so apparently we can tell right away that this is going to be our alpha value, and we can see there is something going on over here. So the fact that we can write that cos of 105 degree, so is actually equivalent to, so cos of 210 degree divided by 2. So that is the relationship between both of them, and according to the formula, so that is going to be our alpha. Sorry, I'm not supposed to use this formula actually. So this is a formula for sine. Added, so let's copy the correct formula. So it should be in term of cos. I don't know why I copied the sine. So, but it's going to be pretty much the same idea. So it's still going to have plus and minus, so you still have to be careful with that. I'm going to paste it here. There you go. Okay, so now let's start simplifying this. So I'm going to apply the formula on this, so for which our alpha is going to be 210 degree. And now, if you have a look at this, we can tell right away whether we should pick between plus or minus for this case. How do we tell? So the fact that the position of the 105. So remember, when we sketch the quadrant, so this is 10 degree, this is 90 degree, 105 degree is actually here. So this is going to be your 105 degree. So it's actually positioned in the second quadrant. And in this quadrant, according to the cast rule, only sign should be positive. Other than that, it should be negative. So therefore, when I copy down the formula, so this should be negative of 1 plus cos 210 degree, so over 2 and square root the whole thing. So that's why we choose the negative, because of that reason. Okay, because we know that cos of this value should be negative because it is in the second quadrant. And then I'm going to start substituting. So I'm going to have 1 plus, so cos 210 according to what we have been given in the question is going to be negative square root 3 over 2. That is going to be over 2 square root. Now I'm going to use my calculator and try to figure out if I can actually simplify this. I'm going to have 1 minus negative. I don't have negative. I don't need negative anymore. So I'm going to have 1 minus square root of 3 over 2. So divide by 2. So there's no way I'm going to be able to simplify this. All right, you know what? I'm going to write it like this. So this is going to equal, if I wanted to simplify this, you can actually leave it in this form. So this is already exact value, but I'm going to simplify a little bit more. I'm going to write that this is going to equal 2 minus square root 3 over 2. So divide by 2 square root with a negative, and this is actually equivalent to 2 minus square root 3 over 4 negative square root. Okay, so that is going to be the simpler form that I can come out of this. But if you were to leave it like this, so that is already exact value. But if I were to simplify, so I can also change it into this form. So that is going to be our exact value. Okay, so next we're going to verify the identity. But before that, let me check the value. So is it going to be the same as what I get from the calculator? Negative square root of 2 minus square root 3 divided by 4. It doesn't matter. So that will be the value then. So next I'm going to verify the identity of tangent alpha over 2. So it should be equal cosecant alpha minus cotangent of alpha. I think this should be a very simple one as long as you know which formula for you to pick. Okay, so I'm going to have, because of this cosecant, I'm going to have something that is related to sine. And this is going to be something related to sine and also cos. And when I have a look at each of this right here, I can tell straight away that I can easily prove that by using this formula. So I'm going to copy this. Now this is going to be super straightforward one. Okay, so I have a tangent of alpha over 2. Okay, according to the property, is going to equal 1 minus cos of alpha over sine alpha. And I can actually separate this. So remember the rule. So if I have A plus B over C, I can actually write this as A over C plus B over C. However, I would like to remind you, if you have A over B plus C, so this is not equal A over B plus A over C. This is completely wrong. Okay, so you can only separate the numerator. So the numerator is separated, but the denominator, you cannot change it. Okay, if it's denominator C, so no matter what you do, it should be still equal C unless you multiply the top and also the bottom. Then only change. Okay, don't separate them like that. Okay, so therefore what I'm going to do is I'm going to apply on this. I'm going to write this as 1 over sine alpha minus cos alpha over sine alpha. Okay, and I know that 1 over sine, we have seen this before, so this is going to equal cosecant of alpha, and cos over sine, sine over cos is going to be tangent. Okay, but cos over sine, that is going to be cotangent of alpha. So this is going to be cotangent of alpha. With that, we're already proven that tangent alpha over 2 is actually going to equivalent to this. That's it. So that is all that you have to do. So we've already proven that. Okay, so basically it's very simple formula for you to use. And as usual, I've prepared exercise for you to do right here. So this is going to be, some of them are using what they call that double angle, some of them using half angle. So try to figure it out on your own. And there's more exercise for you that you can